In the previous TPU printing tutorial, we walked you through loading TPU on the Snapmaker U1, slicing with Snapmaker Orca, and completing your very first TPU print. However, TPU is inherently more challenging to work with, and different brands often require different parameter settings. As a result, many users still run into issues during printing. In this video, we'll focus on the simplest and most reliable workflow for printing TPU, while also covering the most common problems and their solutions, helping you achieve consistently high-quality TPU prints. Snapmaker currently offers two TPU filaments, 95A and 90A. The 95A HF is stiffer, supports higher print speeds, and is generally easier to work with. The 90A version is softer and more elastic, making it more challenging to print. Both materials have been thoroughly tested and tuned. When used with the built-in profiles in Snapmaker Orca, they can significantly improve your TPU print success rate, making them ideal for users printing TPU for the first time. As mentioned in the previous video, TPU is highly hygroscopic and must be stored in a sealed container. When necessary, you should dry it before use and keep it sealed throughout the entire print. If needed, you can follow these videos to dry and seal your filament with the snap dryer, and then complete the loading process. Since we're using the snap dryer, the filament information won't be detected automatically, so you'll need to enter it manually. Update Snapmaker Orca to version 2.3.4 or later. If your printer is already connected to your computer, the filament settings you edit will automatically sync to Orca. If you don't see the correct filament type in the filament section, click the settings icon under Filament Management and import the latest Snapmaker TPU 90A and Snapmaker TPU 95A HF profiles. Then select the correct filament type. All parameters in the profiles are finely tuned based on extensive testing with Snapmaker's official TPU filaments. Using these profiles directly can noticeably improve your print quality. The Snapmaker Orca library includes both official models and user-submitted designs. Every model has been tested and verified by the Snapmaker team, so you can use them right away. Once you import a model, the filament profile and process profile will automatically switch to the project presets. These presets are also the best results from our testing. Slice, preview, and start the print. Because TPU is soft and compressible, it tends to expand and contract during extrusion. This makes dynamic flow calibration unreliable and can negatively affect print quality. Make sure this feature is turned off when starting a print job. Besides filament brands and print settings, TPU print quality is also affected by many other factors, such as storage conditions, model geometry, and the overall maintenance of your printer. In this section, we'll walk through the most common TPU print quality issues, the potential causes behind failed prints, and the corresponding solutions. Because TPU is difficult to control during feeding and retraction, excessive resistance can cause the filament to build up inside the printhead or even squeeze out through small gaps. If this happens, you can reduce the print speed under Speed in Orca and lower the tool change retraction length under Setting Overrides in the filament profile. At the same time, slightly loosen the screws on the side of the tool head to reduce feeding resistance. Stringing and color bleeding are often caused by moisture in the filament, which creates bubbles when heated in the hot end. So the first step is to replace the filament or dry it thoroughly. If the filament itself is fine, you can try lowering the printing temperature in the filament page of the filament profile. If you're comfortable editing models, you can also optimize small or isolated features to reduce unnecessary travel moves and minimize stringing. If the layer lines on your print are too obvious, you can reduce the outer wall printing speed under Speed to minimize extrusion fluctuations. You can also increase the part cooling fan speed in the cooling page of the filament profile. Faster cooling helps the outer walls solidify more quickly, reducing deformation caused by nozzle drag. TPU wipe towers have weak layer-to-layer support and low rigidity, making them more likely to collapse when pulled or bumped. If a collapse occurs, you can increase the width and length of the tower ribs under multi-material. Additionally, when printing with multiple materials, the wipe tower is printed with all involved materials by default. If these materials don't adhere well to each other, for example, TPU and PLA, the vertical stability of the tower will be further reduced. In this case, go to Filament for Features and assign any single spool to the wipe tower. This ensures the outer walls of the tower are always printed with the same material, improving its structural stability. TPU is highly sensitive to resistance along the extrusion path, and even small changes can cause pressure fluctuations inside the nozzle. When the resistance becomes too high and extrusion drops, you may see gaps or dents. Once the pressure builds up, the filament may suddenly surge out, creating bumps on the surface. In this case, check whether the filament tube is bent or loose, whether the outlet of the dryer box is too tight, and whether the spool holder rotates smoothly. Also, TPU tends to build up inside the nozzle, causing partial clogs that further reduce extrusion stability. If you've confirmed that the external feeding path is clear, you can increase the prime volume under multi-material prime tower in Orca. Additionally, increase the number of skirt loops under Other Skirt, so the nozzle performs continuous extrusion before printing the model, helping clear any remaining TPU inside the hot end. If you encounter general printing issues that are not specific to TPU, such as air printing, you can follow the corresponding videos for troubleshooting. If layer shifting occurs, follow the multi-tool head offset calibration tutorial to recalibrate. If the first layer is rough or material builds up and automatic leveling doesn't help, you'll need to run manual leveling. That's all for this video. Thanks for watching.